All right, let's solve some more trig equations. If we're going to solve for x being between 0 and 2 pi, the equation sine of 3x equals 1/2. The first thing is to recognize that since x has to be in between 0 and 2 pi, that means that 3x would have to be between 0 and 6 pi. That's important because that means that we're going to go 3 times around the unit circle. So let me grab the unit circle and start solving this equation. Sine of 3x has to equal 1/2. Okay. Well, sine is 1/2 right here at pi over 6. Right, so that means that 3x has to equal pi over 6. But sine is also positive in the second quadrant. So the pi over 6 angle that's over in the second quadrant is 5 pi over 6. And between 0 and 2 pi, them are the only two times that sine is going to be 1/2. But we have to go around the circle 3 times, all right? Which means that for this pi over 6, I need to find the coterminal angle when we go around the circle again. Which means every trip around the circle, I'm going to have to add 2 pi, which is the same as adding 12 pi over 6. So to these two answers, I'm going to add 12 pi over 6 and get 13 pi over 6 and 17 pi over 6. That's the second time around the circle. And we got to go around a third time, which means taking these last two answers and adding 12 pi over 6 to them. So that would be 25 pi over 6 and 29 pi over 6. So we have our 3 trips around the circle, each time grabbing our 2 answers. Our last step is to get that x alone, so we divide every single one of these fractions by 3. And so pi over 6 divided by 3 is pi over 18. And 5 pi over 6 turns into 5 pi over 18. And in fact, for each one of these fractions, the numerator is going to stay the same, but the denominator turns to 18. And I want to take a look when we get to the end here, that if you notice this last one, 29 pi over 16, that's less than 2 pi. Right? And they're all positive, so they're all bigger than 0. So once we get our final answer, our final 6 answers, all of those do end up being between 0 and 2 pi. So let's use the same process on a few more examples. All right, if we're going to solve between 0 and 2 pi for cosine of 4x is equal to root 2 over 2. Well, if x is between 0 and 2 pi, that's going to mean that 4x is between 0 and 8 pi, which is 4 times around the unit circle. I'm going to grab that unit circle again to help me visualize all my answers. We go back to solving. Cosine of 4x equals root 2 over 2. So we think cosine equals root 2 over 2 right here at pi over 4. And the other spot on the unit circle where cosine is also positive would be in the 4th quadrant, down here. The other pi over 4 that's in the 4th quadrant is 7 pi over 4. So these are our first 2 answers. Pi over 4 and 7 pi over 4. That's for one trip around the circle. We need to make 4 trips around. So for each of these angles, we need to keep adding another trip around the circle, 2 pi, which is, in fourths, 8 pi over 4. So I'm going to take my 2 answers, pi over 4 and 7 pi over 4, and add 8 pi over 4 to that. So we'll get 9 pi over 4 and 15 pi over 4. That's the second time around. The third time around, we add 8 pi over 4 again. So 9 plus 8 is going to be 17 pi over 4. And 15 plus 8 is 23 pi over 4. That's the third time around the circle. For the fourth time around the circle, add 8 pi over 4 again. 17 plus 8 is 25 pi over 4. And 23 plus 8 is 31 pi over 4. There's our fourth time around the circle. Once we've gone around the circle 4 times, we'll go back to the beginning. We have to get that x alone, so divide everything by 4, which keeps all of the numerators the same and turns all of the denominators into 16. And there are all 8 of our answers. How about a tangent? So if we got tangent of 3x is equal to root 3 over 3. Because of that 3x, that means we're going to go 3 times around. If it helps you to remember where tangent is equal to root 3 over 3, well, root 3 over 3 is 1 over square root of 3, and that would be the same as 1/2 over square root of 3 over 2. I think about that because tangent is sine over cosine. So we need to think about where is sine equal to 1/2 and cosine equal to root 3 over 2. That's going to happen at pi over 6. The other place where tangent is positive is going to be in the third quadrant, because that would be when sine and cosine are both negative. So we have pi over 6 for the first quadrant, and the pi over 6 that is in the third quadrant is 7 pi over 6. So those are our first two solutions, pi over 6 and 7 pi over 6. That's our first time around the circle. We need to go 3 times total. So this is the first time. For the second time, we're going to add another 2 pi. And just as a reminder, 2 pi is the same as adding 12 pi over 6. So 1 plus 12 is the 13. 7 plus 12 is 19 pi over 6. That's our second time around the circle. For the third time around the circle, we add 12 pi over 6 again and get 25 pi over 6 and 31 pi over 6. So there's our 3 trips around the circle. To finish the problem off, we have to go back, get x alone by dividing everything by 3, which means all of our numerators are going to stay the same. And instead of being pi over 6 now, we're going to divide by 3 and get pi over 18. So 7 pi over 18 and so on. So there will be our 6 solutions. I just want to point out one more time. Notice that the last solution, all right, that 31 pi over 18, that is still less than 2 pi. All right, so we can be confident all of our answers are going to be correct. One last example here. What about when we have cosine of 1/2 x is equal to negative root 3 over 2? So we have a couple things happening here. First of all, I mean, we're solving for a negative value now instead of positive one. But also, we have a fraction. That's going to mean that 0 is less than or equal to 1/2 x, which is now going to have to be less than half of 2 pi, which is pi. That means that we're only going to take a half of a trip around the circle. So when we're solving the cosine of 1/2 x is equal to negative root 3 over 2, well, cosine is root 3 over 2 right here at pi over 6, which means it's negative root 3 over 2 over here in the second quadrant and also in the third quadrant. So the pi over 6 that's in the second quadrant is 5 pi over 6, and the one that's in the third quadrant is 7 pi over 6. Those are our 2 solutions for one trip around the circle. The thing is, we're not even taking one trip around a circle, we're only taking a half of a trip around the circle. going from 0 all the way over here to just pi. That means we'll only have this one solution of 5 pi over 6. To finish off the problem, we need to get x alone, so we're going to divide both sides by a half, which is the same as multiplying by 2 over 1, and x is equal to 5 pi over 3. So even though 5 pi over 6 is between 0 and pi, our solution x is between 0 and 2 pi.